Well, you might have guessed yet another formula for finding out the population standard deviation. It looks pretty much like our other formula. Now we're summing the same way. Probably easier to sum this time. Let's see. So the situation is I've got 25 ones and 75 zeros. So the sum of the x's is 25 ones plus 75 zeros. It'll be just 25. And sum of the x squareds, the squares are ones and zeros too, because 1 squared is 1 and 0 squared is 0, so the sum of the x squareds is also 25. That's convenient. N is 100. So sigma is the square root 1 over 100 times 25. No, 25 squared is 625 over 100, like that. So that's really 6.25. So I'll go in here, 25 minus 6.25, 18.75, divide by 100, 0.1875. I think that's 3/16. And then take the square root. I get the 4330 we had before. So, you know, half, 6 of one, half of a dozen of the other, like they say. Just get the same answer, it's all cool. And then, we might look on our calculator. How does this look on the TI calculator? So in the first case, where we had our example data set that was -2, 12, 4, 21, 15, we enter it into a list. So we go stat, edit, put it in a list. Then after it's in there, we go stat, calc, one variable. We pick the list. We leave frequency blank. We hit calculate. And we look for this guy here, SX. So on the calculator, S is SX, like that. 13.693, that's what we got. Perfect. And then with the second example with the tokens, we put the token values in list 1. We put the frequency in list 2. So we had 25 ones. So in list 2, I've got 25 next to 1. And in list 2, I've got 75 next to 0. And then in stat calc 1 variable, I'll pick list 1, whatever list you put the values in, and the frequencies are another list here. I said list 1 is the data values. List 2 is the frequency, so now it's actually using the frequency for something. I hit calculate, and now I look for sigma. So this is the population standard deviation. And this is the sample standard deviation. And the calculator has no way of knowing what's going on, so you have to look at it and figure out which one you want, because you have the same set of data values either way. The data values could be the whole population or it could be a sample, it doesn't know. But you'll know when you look whether to choose S or sigma based on whether you want whether your values are just the sample or the entire population. And there we go. I think that almost kills off this section. I'll be back in a few minutes with the conclusion of standard deviation.